Hello, you're welcome to this lesson. In this video, you're going to solve this question I have on the screen. The question says we should express 2 minus I to the power I in the form a plus ib. So let's look at how you are going to solve this question. So we've been given 2 minus I to the power I. Okay, so let's look at how you're going to do this. So first of all, I will write the terms in the bracket as z equals 2 minus I. Okay, and then from here I will find the modulus and then the argument of this complex number z. So the modulus, which I represent with r, will be equal to the square root of 2 squared plus 1 squared, and this will give us the square root of 5. Okay, and then find the argument 2. We're going to have theta to be equal to the tan inverse of minus 1 over 2. Okay, and then when I do this, I'm going to compute this in radians, so let's look at that. So we have tan inverse of minus 1 over 2, and this will give us a value of minus 0.4636. Okay, radians. So this is what we have. Okay, so from here I will rewrite z as, I'm going to have z to equal to 2 minus I. Okay, and this will be the same as the square root of 5 multiplying e to the power minus 0.4636I. Okay, this is what you are going to have. Okay, so I'm going to rewrite the general question that was given. We are given 2 minus I to the power I. Okay, so I can rewrite this as the square root of 5, okay, multiplying e to the power minus 0.4636I, okay, all to the power what? I. Okay, this is what you are going to have. And then I'm going to rewrite this as the, let me take out this bracket. So I'm going to have the square root of 5, okay, to the power I. Okay, and then multiplying e to the power minus 0.4636I squared. Okay, this is what you are going to have. Okay, and you know I squared will give us minus 1, and we already have another minus here, so they are going to cancel out, and then at the end you are going to have 2 minus I to the power I to be equal to the square root of 5 to the power I multiplying e to the power 0.4636. Okay, so what I have here is just a real number. Okay, but we have the square root of 5 to the power I here, so we can focus on that one. So let's look at what we are going to do. Okay, so I will write the square root of 5, okay, as e to the power ln of square root of 5. Okay, this is what I write, and then from here I'm going to get the square root of 5, okay, to the power I to be equal to e to the power ln of, okay, ln of square root of 5, okay, to the power I. Okay, I'm going to have something like this. Okay, and then you know that if I have a to the power b, then I can say that the exponent of the natural log of a to the power b, okay, will be equal to the exponent of b multiplying the natural log of a, right? So I'm going to apply the same concept here. So I'm going to have the square root of 5, okay, to the power I to be equal to e to the power I multiplying the ln of square root of 5. Okay, this is what you are going to have. Okay, so from here I'm going to rewrite this equation again. Okay, so let's look at how I'm going to write it. Okay, so I'm going to use Euler's formulas here. And then it says that if you have e to the power I theta, you can write this as the cosine of theta plus I sine of theta. Okay, and the same thing that we have here. Okay, but in this case our theta will be equal to the ln of square root of 5, right? So let's do the substitution. So we're going to have a to the power ln of the square root of 5 I to be equal to the cosine of ln of square root of 5, okay, plus, let me bring this here, plus I sine of the ln of square root of 5. Okay, so let's simplify this and see what you are going to get. Okay, so I'm going to point to the first one. You have the cosine of the ln of square root of 5, and this will give us a value of 0.6933. Okay, then let's look at the second term too. We're going to have the sine of the ln of the square root of 5, and then that gives us 0.7206i. Okay, so this is what we have now. Okay, so now we rewrote the square root of 5 to the power I. Okay, the square root of 5 to the power I as we rewrote this as this. Okay, and then from there we expanded it into what we have here. So now let's bring it back to this side. So we are going to have 2 minus I to the power I, okay, to be equal to e to the power 0.4636, okay, multiplying 0.6933 plus 0.7206i. Okay, so let's do the multiplication and see what you are going to get. So I'm going to have exponent of 0.4636 multiplying 0.6933. Then this gave me a value of, I'm going to have 2 minus I to the power I to be 1.1022. Okay, and then plus, let's look at the other side too. We're going to have e to the power 0.4636 times 0.7206 I, and then that will give us a value of 1.1456 I. Okay, so this is what you get if you express 2 minus I to the power I in the form a plus ib. Thank you very much for watching this video. Please make sure you like and subscribe.